So I'm George Bendo from the University of Manchester, and I work with the ALMA telescope, which is shown down here, which is a telescope based in Chile. I'm part of a larger group at Manchester called the Interferometry Center for Excellence, which also works with the Square Kilometre Array and with E. Merlin. All of these telescopes are notable for observing at radio and millimeter and sub-millimetre wavelengths. So it's very long wavelength forms of electromagnetic radiation. You see things like molecular gas in space. You can also see photoionized gas in space. At the very short wavelengths, you can actually see interstellar dust. And at the very long wavelengths, you can also see what's called synchrotron radiation, which is produced by electrons oscillating around magnetic fields in space. So a lot of people actually use that to study magnetic fields. This is important in astronomy in general just because it's a huge part of the electromagnetic spectrum where things radiate. Things like molecular gas in space, the best way to study that is really by looking at millimeter wavelengths. It's just very difficult to study at other wavelengths. We also can just understand a lot of things about the universe in general at these wavelengths, which we just wouldn't be able to understand as well at other parts of the electromagnetic spectrum. So just being able to study how individual stars form out of gas clouds, for example, understanding how planets form out of dust disks. These are things that we can do really well in this part of the electromagnetic spectrum, which just be much more challenging if we were to do it in visible light or infrared light, for example.